Hi, my name is Axel Bocciarelli.
And my name is Loïc Huder.
We're both web developers working at the ESRF, the European Synchrotron in Grenoble. Our contribution to the PaNOSC project concerns mostly data visualization for remote data analysis services, and that falls under work package 4 of the PaNOSC project. So our main focus is to build data visualization solutions specifically for the web.
Our initial objective was to integrate a viewer for HDF5 file into JupyterLab. JupyterLab is a web platform that is used by scientists to run analysis code. And this web platform was lacking a tool for users to easily browse, inspect, and visualize their data, which is stored usually in HDF5 files. When we were designing the viewer, we chose also to use web technology because that means that users don't have to download heavy HDF5 files to their machine when they run code on remote servers, so for instance in computing clusters. The viewer also had to support the Nexus format, which is very common for PAN facilities. After surveying existing solutions, we realized that they did not meet the performance and flexibility requirement we had, and so we decided to develop our own web viewer that we called H5Web. Right from the start, we based the H5Web viewer on a flexible client-server architecture. That means that the viewer doesn't have direct access to HDF5 file. Instead, it makes requests to a server that then takes care of accessing the file, reading the data and the metadata that are requested by the viewer, and then respond to requests. This decouples the visualization part from the file access part and is in line with current web standards. And still on the technical side, the performance requirements were met by using a technology called WebGL. WebGL makes use of the graphic card for visualization rather than the processor of the computer, and this allows to have faster processing of visualizations. After all this, once we released a stable version of the H5Web viewer, we reached our initial target, which to add a viewer in JupyterLab by wrapping the H5Web viewer in a JupyterLab extension. This way, users can install locally the viewer, or facilities can install the viewer in their own Jupyter infrastructure.
First, Jupyter notebooks are very popular with scientists, and not only in the photon and neutron community. So providing a solution for viewing HDF5 files in JupyterLab, we're hoping is going to make it much easier for them to analyze their data in general. But right from the start, we knew that other web applications than JupyterLab, like data portals, would really benefit from integrating an HDF5 viewer. So yeah, because data portals are crucial to make open data accessible from outside of PAN facilities. But when you have to download huge HDF5 files and write scripts to inspect and visualize the data and so on, it can get pretty tedious, so it makes the data less accessible. So thanks to how we designed H5Web's architecture, we recently managed to integrate it in the ESRF's data portal. So users can now just click on the button and next to any HDF5 file that they find in order to open it in H5Web. So they don't have to install any software, download any file, or even leave their browser. So H5Web is flexible enough that it can be integrated into other web portals and applications for remote data analysis. And we're happy to report that other facilities and organizations have successfully managed to do so. So for instance, H5Web is now available in Nomad, the portal for material science data, and also in Visa, which is the remote data analysis portal developed as part of PaNOSC. So the last thing I'd like to mention regarding Fed data is Nexus. So to our knowledge, H5Web is the first generic web-based HDF5 viewer that supports the Nexus standard. And so, for instance, it can show meaningful default plots right when you open the file, which is really convenient to quickly see the most interesting data in your files. So we hope that this will help promote the Nexus standard and therefore just interoperability between facilities. Yeah, sure. So this is JupyterLab running on the cluster at the ESRF. Here I can see I've got an HDF5 files in the left-hand side, and I can just double-click on it, and it opens it directly in H5Web. So this is what H5Web looks like. Right away, you can see that you see the default plot that I was talking about with Nexus, right? And it's got a spectrum interpretation. And it's just a simple data set with 1 dimension and 1,000 points. So I can already just use the toolbar to change the scale of the axis. For instance, here I can zoom with the mouse wheel. I can also zoom by drawing a box. There you go. And I can go back to the start. So as you can see, this is very fluid, and that's because we use GPU rendering, right? So as we mentioned earlier. What we can do now is inspect the metadata of the entity that we're currently viewing. We can see the default plot pointing here to an entity with entry 0. We can click on it to navigate, then again, and so you can then access the signal directly, the signal data set, the underlying data set. If we go to a bigger data set, this one, for instance, has 10 million points, and now I can switch back to display to show the image visualization. So as you can see, this loaded pretty fast, and that's because we're only basically fetching the first slice of the stack of images. So it's 10 images of 1 million points each, and I can, select another slice, and it will fetch the data and display it. So it's really important for the web because you're far from the data, so you don't want to download too much to save bandwidth. So here I can again use the toolbar to change the color map. I might just change the scale first. Simlog, yeah. So I can change the color map. I can change the range, and again I can zoom in, and as you can see, it's always very smooth. So we've got additional features like swapping dimensions. We can also inspect the raw data, download it as in different formats, and so on. And that pretty much covers the core features of H5Web.
Yes, when we started working on H5Web, we quickly realized that the visualization component we were building could really help develop better data analysis application on the web. Because as we saw from our survey, the existing data visualization libraries like Plotly really struggle with large amount of data and don't provide the level of interactivity and reactivity that users have come to expect on the web. And so that's why we decided to make H5Web's visualization component available in a separate open source library. The first adopter of this library is a viewer for diffraction image called Braggy, and the work on Braggy really helped to drive the development of H5Web's library in the right direction. Braggy is now in production at ESRF for macromolecular diffraction beamline, and I can give you a quick demo of it. So here is the Braggy interface. So it looks a bit like H5Web, but in the browser here we have file and not content of an HDF5 file. And the files that we can look through Braggy can be any kind of files. It can be CBF image or dataset inside HDF5 file. I will just open a CBF file by clicking on it here. And as you can see, here we recognize the H5Web visualization component that we use to display image in the HDF5 file viewer. But in this case, it is used in this Braggy application to display diffraction image. And so while we can use common components, such as changing the scale, changing the color map as in H5Web, we could also extend the functionality of H5Web by adding specific component for diffraction data. So for example, this diffraction rings that shows the resolution of on the image. And we can change also the color of these rings, and these are components that were developed specifically for Braggy, but in the frame of the H5Web visualization components. we have started to look at integrating H5Web into the web-based acquisition software that some beamline use at ESRF. The goal is for scientists and beamline users to get visual feedback as early as possible during their experiment to optimize the acquisition process. We are also actively working on visualization components that can handle very large tomography reconstruction. So we are working on optimization features such as displaying only subparts of data and adjusting the level of detail based on the zoom level. And recently we've also received a great contribution on the code base from a developer who made a library to read raw HDF5 files directly in the browser. So that means that it will soon be possible to open local HDF5 file in H5Web without the need for JupyterLab or in fact any solution that serves file from a server.
As we mentioned earlier, the H5Web viewer is already available at many facilities and can be installed really easily on a local JupyterLab instance, for instance, just on your local machine. So it's free and open source, so we encourage people to just try it out and send us feedback. The development is really driven by user needs, so we count on our users to tell us what they need and why they need it. So please get in touch. The easiest way to send us feedback and questions is to use the mailing list URL h5web@esrf.fr, and you can also visit the project repository on GitHub to leave an issue or even contribute if you want. Thanks, bye.
Bye.